And on this question, we're going to be using Cramer's rule. Now, if we're missing parts, one of the variables, then we plug in zeros. So when we make up our matrices, we need to make sure we put in the zeros for those determinants. Okay, so I'm going to write it down, and I'm actually going to plug in the zeros, just so we don't make mistakes with these. So when I write down question 9, I've got a minus 5x. Now that first equation, we have no y, so that's going to be a plus 0y plus 3z, and that equals now 16. So I'm going to plug in the zeros just to make sure we have them. The zeros are just the placeholders. And then we've got 7x plus 5y minus 9z equals a minus 26. And then we've got a minus 3x minus 7y plus 0z equals negative 45. Okay, so that's what we've got so far. Is everyone okay with that? Now, we are asked to solve this one using Cramer's rule. So that means we need to get our determinants. We're going to have to do 4 3x3 determinants. So we're going to start off with what I call the master determinant, D. And what is D? Well, D is just all the variables lined up. So that's x, y, and z. So we have a minus 5, 7, minus 3. We've got 0, 5, negative 7, and we've got 3, minus 9, 0. Is everyone all right with that so far? So you need to make sure you plug those zeros in, make sure everything is written correctly. It is so easy to just copy something down wrong, and then it doesn't work. Now, if you start getting fractional answers, you know you made a mistake. Now, we need to use our cofactor expansion. I can either go down the side or across the top. I am going to go across the top because of this 0 here. Right? Wherever you have a 0, it's going to make it the easiest. Because that takes it to 1 less. Because that 0 is going to cancel out 1 of them. So let's go across the top. So we're going to circle that negative 5. Now remember how your signs go. Plus, minus, plus. Right? So that's how your signs go. So what do we have now when I expand this out? Well, we've got negative 5. And when I cross it off, what's my determinant? 5, negative 9, negative 7, 0. Is everyone right with that? Okay, so that's our first one. Now, what about the next one? Okay, the next one is going to be this 0. But we don't have to really worry about it. We'll write it down because it's 0, but what's my determinant? Well, if I cross that off in a T like this, 7, negative 9, minus 3, and 0. Now, we don't have to worry about this at all because 0 times anything makes it what? 0, and so it's gone. Now we've got one more. And what's that last one? And this should have been a negative here, but 0 doesn't have a sign anyway, so it doesn't really matter. What about the next one? What about the last one? With the 3. Again, how do we cross these off? Down the side and across. Okay, if I cover those up, what's left over? Looks like 7, 5, minus 3, minus 7. So we've got 3 out in front, and then we've got 7, 5, minus 3, and minus 7. Is everyone all right with how I built those? Right, so we just, like on this one, we take our 5 there, cross it off, across the top, down the side, and that gives you that. We do the next one. Now, 0 doesn't really matter, right? Because 0 times anything makes it what? 0, so it's gone. Now, it should be a minus, but 0 doesn't even have a sign. So we don't have to worry about that at all. And what about the last one here? Well, it's 3. Okay, we cross it off, and that's 7 and 5, minus 3 and minus 7. Now we can evaluate this down. So that's going to be a minus 5. And remember, how do we work this out? We multiply and subtract. We cross multiply here and subtract off. So that is going to be 5 times 0 minus, and watch for all the extra negatives there, a minus 7 times a minus 9. 5 times 0 is 0, of course. So that's going to be a minus 5. Triple negative keeps that negative. And we've got 7 times 9, that's a 63. And triple negative keeps it as a minus 63. So that piece is going to come down. Let's do the other one. The other one is 3 times 7 minus 7. Remember how the determinants work. And then what do we have? Then we have a minus. Use parentheses, minus 3 times 5 there. And then that gives me then a 3. And we've got now 7 times a negative 7. Well, that's a negative 49. A double negative here makes that a positive 15. Okay, we're going to break this down. 5 times a negative 63. It's negative and negative makes it a positive 315. And then we've got a negative 49 plus 15 times 3, that makes it a minus 102. And 315 minus 102, that makes that 213. Is everyone all right with how I did that? Make sure don't make a mistake. If you see a mistake, don't hesitate to tell me. It's so easy to accidentally make a wrong sign error if you're not really, really careful with these. Okay, so next part, that's our D. So we've got our D. Next part, we'll do dx. And what is dx? Well, dx, we replace the x with the equal sign, and then we need the y, and then we need the z again. So they're going to be now, if I go back up and I look, replace that negative 5 with a 16, a minus 26, and a minus 45. Then we've got y, which is 0, 5, and negative 7. And we've got z, which is 3, negative 9, and 0. Is everyone okay with that? Remember, whatever variable down here is your subscript, you replace it with what's on the equal sign. Okay, now we factor across. We're going to go across the top again, y, and we're not going to go down the side because this 0 makes it easier. It's one less determinant that we have to actually break out and work with. And the signs again go plus, minus, plus. So 16 comes down, and if I cover it up, got 5 and negative 9, minus 7 and 0. So 5, negative 9, minus 7 and 0. That takes care of that. Now, this piece I'm not even going to bother writing down, right, because it's a 0 there. So we can write it down. Just so we don't lose it, I'll go ahead and write it down, but it doesn't matter. Right? We're not going to break it up. Why not? Because 0 times anything is still what? 0. So we don't even need to worry about that. That's gone. That's why we use zeros. Anytime you have a 0, it makes your life a lot easier. What about the last one? The last one is plus again. And let's write it down. Okay, if I cover up the 3, What does that leave you with? And the numbers are large now, and that's okay. We have a calculator. That leaves you with a minus 26 and 5, minus 45 and a minus 7. So minus 26, 5, and then minus 45 and minus 7. Okay, so we're almost done here with one of them. Now we've got to break up our determinants. So let's go ahead and break this up. The middle one is gone. So the good thing is we don't even have to worry about the middle one because it's done. And what do we have here? We have 16, and that's going to be 5 times 0. Well, that's gone, so we don't have to worry about that. Minus, parentheses, a minus 7. Times a minus 9 again, right? Because that's what we're working with here. This is 0, so it's gone. Then we've got 3 times, and we have to be very, very careful with our signs and everything that's wrote in here. Okay, make sure I copied it all down correctly. Okay, so make sure that's a 7 there, not a 9. So easy to write anything down wrong, the whole thing will be wrong. So let's make sure our matrices is right here. Everything looks right. Okay, so it's going to be, when we cross multiply again, I like to draw the arrows. And what do we have? We have a negative 26, right, times a negative 7, and then we have a minus 45 times 5. Now, the numbers are larger, but that's okay. We have a calculator. So let's go ahead and work this out. We've got 16. Triple negative keeps it negative. And we've got 7 times 9, so that's a negative 63 there. Then we've got 3, and what do we have here? Okay, we have negative, and negative makes it positive. So 26 times 7, that's a 182. 2 negatives make this positive, and that's 45 plus 5. Sorry, not plus 5. 45 times 5. Make sure we're careful there. That's 225, and it's positive there, right? Because 2 negatives keeps it positive. Now we can work it out. 16 times a negative 63. That's a minus 1008. And then we've got, we'll add these together. So that's 182 plus 225. We'll multiply that by 3. And that's 1221. We put those together. So minus 1008 plus 1221. Add those together, and that comes out to then be 213, right? And that was dx. Now, what do we know? We know that x is dx over d. We found dx to be 213. D was 213, and so that gives you the first piece, which is d, which is that x equals what? 1. And again, I'm not going to put anything on this level of difficulty on your exam. On your exam, you're going to have systems of equations, but 2 variables, 2 equations, that's it. I'm not giving you 3, but we do need to still at least cover some of them in your homework. So if you go on and you take Calculus 1, you'll at least have seen these before. If you go on and take more mathematics or physics, you're going to use a lot of systems of equations. Systems of equations are used in physics when you have multiple things happening at once. So multiple different aspects, like when you look at a car, and what happens at a certain point with the car and the braking. Well, there's lots of things go into factor. The weather, the type of car, all those things go into play. So that's why if you take a physics course, you'll work with a lot of these. Where they were first used is in astronomy. And they worked with the planets and how they rotated around the sun. So those are systems. And historically, they've been done by hand. In the last 100 years, we use a computer, and it really helps out a lot. Same thing with business forecasting. If you work for a large company, large corporation, there's a whole department, like for Walmart, for example, that does nothing but calculate what they expect the sales to be. And there's so many variables, hundreds, if not thousands, and so that's based upon these. Let's finish this one out. We still need to do dy. And dy is x, the equals, and the z. So let's go ahead and fill out dy. So dy, I'll put this up here so we can see what we've got. dy, remember we replace the y with the equals. So we've got minus 5, 7, and a minus 3 for the x. The y gets replaced with the equals, which is 16, minus 26, and minus 45. And then we've got z, which is 3, minus 9, and 0. Now, how can we work this out to take advantage of that 0? Well, we can go down any row or across any row or down any column. We have a 0 here, so we can either go across the bottom or down that last column. We want to use that 0 and use it to our advantage. So I'm going to go down this last column. I'm going to go down z. It doesn't matter which way you go. And the signs always switch, plus, minus, plus. And if you take another math course in linear algebra, you'll learn a lot more about these, how they came to be and what they're useful for. Right now, we're just kind of touching on them a little bit. But if you take a linear algebra or a matrix algebra course, you'll derive determinants, you'll understand more of what they are. And why am I going to go down this way? Because that 0 is going to make it easy. We want to use zeros to make our life easier. So we have a 3, and if I cover it up, what's left over? It looks like 7 and a minus 26. And that's a positive 7 by the way there. Positive 7, yep, and a negative 26. And we've got then a minus 3 and a minus 45. So there's that one. And watch your signs, because remember, the middle sign is negative, so that's a minus 9, because that's the number in front, because we're going down that column, right? And let's see what we've got there. Okay, we go down this column and we cover it up. What do we have? We have 5 and 16. And we've got minus 3 and minus 45. Now, I could have just went across the top, but if I did that, I'm going to have to do an extra step. So why not exercise that 0? Because this is all we have to do, because if I look at the 0, well, we'll write it down, but it's gone, because we've got 0 here and here. Right? And so that gives me then a minus 5 and a 16. Crossing off, and a 7 and a minus 26. Well, that's gone, right? 0 times anything is 0. And this is going to be positive here. Let's evaluate down our determinants. So, what do we have? We have 3. And we cross multiply. So that's 3. And then we have 7. That's a minus 45. Minus, watch all your negatives here, a minus 3 times a minus 26. So there's that. Then 2 negatives in front makes it a positive 9. And then what do we have? We have 5 times a negative 45. When we look down, and then we've got negative out in front, and a minus 3 times that positive 16. Does that Doing all right with that so far. Now the last one we don't have to worry about because it's 0. 0 times anything is still 0. So now we've got 3, and we've got 45 times that 7, and it's a single negative, so it stays negative, so that's a minus 315 there. A triple negative keeps that negative again, and 26 times 3 makes it a 78. And then we've got 9, and 45 times 5, 1 negative stays negative. And the next one, 2 negatives, makes that positive. 3 times 16 makes it a positive 48. Hopefully I won't make a mistake here. It's just so easy to make one little mistake. But think about 100 years ago having to do all of this by hand. See, it would be a whole different deal. So we're really fortunate that we have calculators. And we've got 225 that is negative and a 48 that's positive. So that makes it a minus 177 there. Okay, and putting these together, 3 times 393, that's 1179. 1 negative stays negative. Oops, sorry about that. Make sure you see that's negative. And 9 times 177. That's a 1593. Put those together. So we've got 1179 minus 1593. And that gives you a minus 414. And let's make sure we didn't make a mistake. So let's make sure we didn't make any mistakes. I don't think that's going to come out to be a whole number, but let's double check and make sure. It's so easy to make a simple mistake here. Okay, so we went across. So there's that. Let's just double check. Take your time with these. I know they're not much fun to do. I make mistakes with them too. Okay, looking down the side, double negative, made that positive. Crossing here and here, and that's 5. Oh, there it is. Yep, I knew there was a mistake somewhere. When we look here, it should have been a minus 5. My mistake. Okay, so minus and minus makes that a plus. So that is then going to change that into be 225 plus your 48, which is 273, and hopefully that'll fix it all. So that should be a positive 273 there, which is then a positive. Sorry about the mistake here. It's just so easy to make a mistake with these. You have to be really, really careful. Take your time. 2457. 79 plus 2457. That comes out to then be 36, and hopefully, no, that's still not. Let's make sure we don't make a mistake anywhere else. Okay. Oh, wasn't careful. This should be a negative. My mistake. So let's rewrite it and get it all to work out. I think that's the last mistake there. And that should be all of them now. So what do we have? 3 times 393. It is a negative. So that's going to be a negative 1179, right? 1 negative keeps that negative. Then we have a positive 9 times 273, and that is a 2457. And now we can take them away from each other, and hopefully we get something that's going to work. So that's 1278, and that gives me then y equals, so that's your dy there. So y equals now, hopefully this is going to work. Double check and make sure. Yes, it is. Okay, so we get all the mistakes taken care of. Y is dy over d, which is 1278 over 213, and that now comes out to be 6. So we know we did it correctly because we got a whole number. Now you can definitely see why I didn't put any of these on your exam, because it takes a long time and it is so easy to make one simple mistake. But I did want you to at least see them. So if you go on and you take another math course, or you take a physics course, at least then you've at least seen some of these. One more part of this, and then we will move on and answer questions off of the practice final and the take-home final. So one more of these, and we need to do DZ, which is the last part here. Okay, and what is DZ going to be? DZ, when we write up our determinant, x, y, and we replace the z with the equals. So what is that? That is a minus 5, 7, a minus 3, down the first column. Then we have 0, 5, and a negative 7. Right? And then we replace the z with the equals, which is 16, minus 26, and a minus 45. Now, we're really lucky because we have, again, a 0. Right? So that's what we're going to factor across. We're going to factor across the top row because of the 0. Anytime you have a 0, that's where you want to go. If you take more advanced courses, you'll learn how to create zeros and make your life a lot easier. But we just don't have those skills yet. So we just have to go with the zeros where they're at. But if you take higher level math courses, you're going to learn how to use different row operations to make it easier. This is how a computer does it because, of course, a computer can do millions of calculations a second. So for it, there's nothing really to do. It does these in a split second. But doing them by hand takes a long time. Okay, so let's go ahead and go across the top. How do the signs go? Plus, minus, and plus again. So we have a negative 5. Cover it up. And that is 5, negative 26, minus 7, and a minus 45 for that determinant. Make sure everything is copied down right so we don't have any sign errors. The next one is going to be, of course, 0. And that leaves me then with 7 and negative 3. Looking down. And minus 26 and minus 45. Now that one's got a 0 in front, so our life is easier because that's gone. And the very last one, what do we have for the last one? We factor down because we're going across. So we've got a 16 in front. All right, so that's our number in front. And what's our minor look like? This is called the minor. The determinants are left over. What we're doing is called cofactor expansion. These are our cofactors. And what's left over is the minor. Okay, when we cover it up, we've got 7 and 5. And we've got minus 3 and minus 7. Okay, so what do we have left? We have minus 5. And again, write up what we've got. Be very, very careful with the sign. It is so easy to make a mistake with the signs. So that is 5 times a negative 45 minus a minus 7 times a minus 26. Middle's gone. That's done. And we've got 16. And we've got, working out our minor, we've got 7 times a negative 7, right? Minus 5 times a negative 3, crossing up here. And we are almost done. And this is the last part of the only question we asked about. So we're going to look at our practice final next. And we've got 45 times 5, 1 negative, keeps that a negative, 225. And then 3 negatives makes it negative again. 7 times 26, that's a minus 182. And then we've got 16 7 times a negative 7, well, that's a minus 49. 2 negatives makes it a positive 15. Okay, let's hope we did it right. So these go together, 225 plus 182. That's a minus 407 here. We've got a minus 5 out in front. And then we've got a 16. And we've got 15 minus that 49. That's a minus 34. Okay, let's hope we got it right here. Double negative makes it a positive. So 5 times 407 makes it a positive 2035. Single negative makes that negative. So 16 times a negative 34 there. Makes it a minus 544. And then we'll put those together. And we end up with a minus 1491. And it works. Okay, so what does our z look like? And z is dz over d, which is minus 1491 over 213, which then comes out to give us 1 divided by 213. That comes out to give us a negative 7. So what is my answer now? After all this work, what does my answer look like as an ordered triplet? X, Y, and Z. And what does it look like as an ordered triplet? It looks like 1, 6, and negative 7. And I know that was a lot of work. But if you go on and you take any further math courses, this is the kind of problems you're going to be likely to see. Things that take several pages to go through. If you take a calculus course, expect not like this, but problems that take several pieces of paper to work out. In college algebra, we don't have a lot of these intensive problems, but if you take a calculus course or even statistics, they may take several pages of paper in statistics to work out something as well. So this is kind of a preview of what you'll be facing as far as how much work is involved in the next courses. Okay, so does anyone need the practice and take-home final? Does everyone have that? Anyone need the practice and the take-home final? All right, now. Yep, I've got one. If you need that, I've got the key for it as well. And I know I passed this out about a month ago. So what you've got is here's the answer key for it. And here you go. And there is your practice final and the take-home final. Now, what's going to happen is today we're going to go over some questions on that practice final and the take-home final. We're going to do that on Thursday. Now, what do I expect you to turn in next Thursday on December 15th? What you're going to have all your homework, and make sure that you turn in that packet as well with the take-home final and the in-class one. Now, work out the take-home final. That is going to be graded. It is for a grade, and it's in the back. Right after the practice final, you'll see the take-home one. It's basically the same thing, different numbers in a different order. Your final is going to look exactly like that. You're going to know what is on that final. And hopefully some of you have had a chance to kind of look through some of these. Do we have any questions to look at? Any of these that you would like for me to go over with you? If you had a chance to look at any of them. Did we have anything to look at? Anything to look at? On the take-home final, right? Okay, yep. And which one, 27 or 7? 7, okay. We'll look at that one. Okay, so I'll work out that one. Any others to look at? I don't know if you have this or not, but I don't know if you have the take home final practice. I passed that out about a month ago, so some of you may not have brought it with you, but if you didn't, I've got copies. Okay, so any others besides 7 to look at? How about I'll add a couple just so we have some time to go through. How about 9? Okay, 9 is a mixture problem, so we'll look at 9. Now, I'm not going to work these out, all right, but I am going to set them up for you. Make sure I'm right. 9 on that take-home final. Did we have any others to look at and go over today? 26. Sure, 26. Okay. And that one, we haven't really talked about that, but that one's going to have to be reverse FOILed out. 35. Yep, sure. 35 as well. Okay. And 40. That should take up most of the class period. Whatever time we have left, if we have quite a bit of time, then we'll break up into groups and you can work together on studying for your final. I don't think we will, because I think this will probably take up the rest of the class period. And if we just have 10 or 15 minutes left, you may be leaving a few minutes early. These are the ones that we've asked about so far. Now, I expect on Thursday that you go ahead and work through, because part of your homework on today is going to be start working on that practice final and the take-home final. So Thursday, when we meet again, hopefully you have a lot of questions. And if you don't, then we'll just break up into groups and utilize the rest of that time on Thursday. But if you have questions, I'll help get you started. So we're going to look at, and this is the take-home final. So this is the one that will be graded. And we're going to look at the take-home final, and we're going to look at question 7. Now, I am not going to work it out completely. But what I am going to do is get you started. So let's look at our take-home final, question 7. This is a mixture question, and on your final exam, you are going to have pretty much the exact same question. Except instead of it being a 40% and a 20%, it might be a 15 and an 80%. I don't know. But you're going to have something very, very similar. Because when I made it up, all I did was I switched the percentages and I changed the amounts. So what do we have here? It is necessary to have a 40% antifreeze solution in the radiator of a certain car. So that's what we want. The radiator has 60 liters of a 20% solution. How many liters of this should be drained, so that's negative, and replaced with 100% antifreeze to get the desired strength? So, when we write this up, this is a mixture question. So that means we make our boxes. And 1 plus 2 equals 3. That's the way I remember it. 1 plus 2 gives you 3. So these add together. And then we look at the amounts. And then we talk about our percentage rates for each one. So box number 1 is what we have right now. And as of right now, the car comes into the shop with what? The car comes into the shop with a radiator that has 60 liters of a 20% solution. Is everyone okay where that came from? Why that went in box 1? Right? That went in box 1 because that is what we have right now. Right? So that's what we've got right now. Now, what about the second one? The second one is our pure. So, do we know how much pure we're going to have to add in? No. So that's unknown. Now, the concentration of that is 100. And this is going to be on the right-hand side what we end up with. All right, well, what do we want to end up with? When we are done, we want to have the car still full, so it's still 60 liters, and we want that ending percentage to be what? 40%, right? Now, it's not going to work the way it is, because when we work with these, if I just add in the pure, what's going to happen? It's going to overflow. So again, drain and replace. So this first one becomes a 60 minus what? X. And I'll do one more step to get you the equation. And the pure is the amount times the rate. And so what would that be? That would be 0.2 for the first one times 60 minus X. So that's our first one here. We're going to add to that the pure, which is 100%, which is 1, times the X there. And then what is it going to equal for box 3? Okay, box 3 is 60 times what? The 0.4. You're going to have to finish it. That's all I'm going to do. Is everyone okay with how I set that up? So, make sure you understand how to do this on your own. Because I'm not going to be here on your exam guiding you through the process. You have to know how to set it up. So make sure you see how it works. So one of them is X for the middle, and then the other one for box 1 is 60 minus the X, or 30 minus the X, whatever it might be. You can finish it from there, but that's all I'm going to do. Go back and look at the practice exam if you need to. And just so you know, that one corresponds with question number, let's see, where is it? It looks like question number 29 on the practice exam. Okay, so it looks like question 29 on your practice exam. If you need to reference that. Question 9. I picked question 9 because it's very, very similar to question 7. So if we're doing a mixture one, we might as well do both of them, because this is where students struggle the most. They struggle the most with the mixtures. So let's take our time and discuss it. A chemist needs 110 milliliters of a 73% solution. But he only has a 68% and an 89% available. How many milliliters of each should be mixed to get the desired solution? Now, let's start by picking this apart. A chemist needs. So what does that mean? The needs, that means that's going to go in box 3, because that's our end result. So this needs, that goes in box 3. So that's what we need. Okay, that's the needs right there. So we need what? We've got an amount, and we've got a percentage rate. We want to end up with 110 milliliters for the amount, and we want it to be a 73% solution. Is everyone okay with that? So why did it go in box 3? Because that is the needs, right? And that's what you want to end up with. At the end, this is it. This is box 3. That's what we want at the end. So when we're done mixing, we should get box 3. Okay. What do we have to start with? Well, we don't know either of the amounts, but we have a 67%, and we have an 89%, right? Okay, now, do I know how much is in either one of them? No. So the first one is completely unknown, so I'm going to represent that with the variable x, all right? Because that's unknown. What about the next one? Well, we can't just use x again. And I know it's been a while since we talked about these, but what am I going to use? I'm going to use, again, the total minus x. And what's my total? Amount. Total amount is 110, and that's going to be 110 minus what? X. Okay? I think I'm going to leave this for you to finish. I'm not even going to build the equation. You should be able to build the equation on your own. We just discussed how to set it up correctly. And this looks like question number 30 on your practice exam. So that's going to be like question 30 on your practice exam. Right, so you can build the equation and you can finish it. So that took care of 7 and 9, which were the two mixture questions. 26 is next. And 26 wants us to make sure we're on the right test here. Okay. These are on the practice, not the take-home. Question 26, they give you this. Okay. On question 26, this again is on your take-home final. They give you 8i and negative 8i for the solutions. Okay, so what does that mean if these are solutions? All right, if these are solutions, then that means that this is x equals 8i, right? And this one is x equals a what? Negative 8i. Now, what we're going to be doing is we're going to be working them backwards. So if we want to set everything to 0, so if I set this one to 0, we end up with x minus 8i equals 0. And if I move this one over, then what do I end up with here? X plus, let me write it out correctly here, plus 8i equals what? 0. Now, I want to come up with the equation that it came from. So that means these two multiplied together give me 0, right? So I need to figure out what the roots are, rewrite them so they're equal to 0, and then multiply them together. We are going to end up with the polynomial that it came from. This one's so simple, I'm going to go ahead and work it out because there's not a lot to it. But make sure you understand the process. Because I can't really partly work this one out because I want you to see what's actually happening. Okay, so what do we do with this? Well, I need to break up the parentheses, and how do I do that? I use the FOIL method, right? Remember the FOIL method? Okay. So we're going to take this and we're going to FOIL. If I FOIL, what do I have? X times x, that's an x squared. Okay, so we're foiling. Remember how to FOIL. And then we have outside and outside. So that's a plus 8ix there, right? So that's that piece. And then on the inside, what do we have? We have a minus 8ix. And what do we have for the last piece? Minus 8 times positive 8, that's a 64i what? Squared. Now, if we did it correctly, what happens to the 8ix and the negative 8ix? You should always do this on this case. What's going to happen with these? They're going to go away, aren't they? Right? Now, remember, what do we know about I squared? I know it's been a while since we looked at 1.3, but remember from a while back, I squared is what? Negative 1. Okay, so that makes that a negative 1 there. And then what do we have? Okay, we are left with an x squared. Negative and negative makes it a positive 64. And that equals what? 0. How can we check and make sure we did it correctly? Okay, we have our answer, and this is the answer. But let's see if it makes sense. Let's see how we could check it. How would you check x squared plus 64 equals 0? Well, I would move that over. Okay, and then how would I solve it from here? Does anyone remember how you would get rid of that x squared? Square root property. Okay, and what happens with the square root property? Plus or minus, right? And what's the square root of 64? 8. It's negative underneath. So what do you get out for your two solutions? Plus or minus 8 what? I, which is the same thing as what they gave you. So what we did was we worked backwards. We took the solutions and we came up with the polynomial that makes it work. Is everyone okay with how we did that? And there's another one just like it on your practice final. And the one on your practice final is question number, I can find it just by looking at our solutions. It looks like it's going to be question 28, I believe. Right, question 28 on your practice final. You look at 28, it should be the same thing basically. But what about 28? Okay, 28 is 4 and negative 4, right? So that's going to come out to be x squared plus 16 because 4 squared is what? 16. You can even skip steps and think about it like that. And so this would be x squared plus 16 because 4 squared is 16. This question is designed to be easy. I don't want you to miss this question. I want you to know how to do this question. Make sure you don't make a mistake because this is one of the easiest questions on the exam. I don't want you to make a mistake with it. All you have to do is basically square it. Two more. We've got 35 and we've got question 40. So let's look at question 35. And 35, there's very, very little on this one. So I'm going to have to work it out completely for you because I can't just work it out part way because there's so little to it. And a lot of these are this way. This goes way back to 2.2 when we talked about circles. Now, when we talked about circles, we had a way to write our circles, and that was called center radius form. Okay, so let's write up that formula just so you have it. And let's talk about center radius form. And center radius form is x plus h quantity squared, y plus k quantity squared equals r squared. And the center, remember, was switching the sign. So that's minus h minus k, and your radius is r. So let's take a moment to talk about our formula. So we have to, when we write up our formula here, remember, this is your radius. We have to square it, don't we? Right? Now, what happens to the signs from the center to the center radius form? What happens to the signs? They switch, right? So this one, there's really not much to it. So let's now rewrite this in our center radius form. We've got x plus, right now it's 0, right? That's our h. Still stays 0, quantity squared. And then we've got the y. And what do? We switch our signs. So y is a 7, so it's y what? Minus 7, quantity squared. Remember, you have to switch your signs. So when it goes from the center to the center radius form, what do you have to do? Switch the signs. What about on the right-hand side? You've got the square root of 5, but what do you have to do to it? Square it. Now, what does that look like? What's our final answer going to look like? That 0 is gone, so this becomes then what? X squared. What's left for the y part? Well, that's y minus 7, quantity squared. And what happens when we square a square root? Does anyone remember? It goes away. And so that makes it then what? 5. Now, you are going to see a question very, very similar to this on your exam. This is another question that I do not want you to miss. I picked this question to make sure that you understood center radius form. It's designed to be very easy, and basically if you know what the formula is, free points. You'll find a lot of these. A lot of the questions are not difficult. They just check different concepts. So on your final and your practice final and the take-home final, there's not a lot of questions that take multiple pages of work. They're going to be quick, easy. Do you understand the basic concepts? And the last one that we asked about, and we can add more to the list if we need to. The last one that we asked about was question 40. So question 40. Let me draw it right here. Okay, so these are our dots here, and dot here. And this is at 2, -2. And this one's at -2, +2. And this is f of x. All right, so I give you this graph. So that's what we've got. Okay, so that is given. And this one is another one that I can't really partly work out. I'm going to have to completely work it out so you understand the concepts again. So this is f of x. Now, if we read it, what do we want? We want the graph of 2f of x, right? So this is basically y equals f of x. And we want y equals 2. F of x. Now, what is that going to do to my picture? Think about it like the slope. Okay? If it was 1, 1, we would go up 1 and over 1, right? But what is it now in front of this? 2, 1, right? So we go up 2 and over what? 1. So what's going to happen to my numbers? It's going to be taller, isn't it? Right? We're not moving it left, right, in. We're not changing this at all. We're just going to make it twice as tall. So what would it now look like? And what does it mean? Okay, if it's twice as tall, that means you multiply the y values by 2. If there would have been a 5 in front, what would you multiply the y values by? 5. Okay? X values stay the same. Remember, this is your X and this is your Y. So let's multiply those values by 2. We have to double them. So there's our original. Move it out so we can get a better picture here. I'm going to try to keep the original up on the screen so we can see it. Now the first point is minus 2, positive 2. So it's still at minus 2, but instead of it being at 2, we have to double it. And when we double 2, what does that make that now? 4. So this new point is going to be way up here at minus 2, 4. And what's my other one? Okay, my other one is forward 2 units, but down now what? 4. 1, 2, 3, 4. And so that makes that point now 2, negative 4. And now when we connect them together, we just basically copy the picture and look at what happened to it. So what happened to my picture now? It's twice as tall, right? Now, if that number would have been, let's say, a 5 in front, if this would have been a 5 here, what would it be? 5 times as tall, right? And if it was a half, what would it be? Half as big. And if it was negative, it'd be flipped upside down. I'm not going to give you negatives, but it would be flipped upside down. So do we understand what that number in front does? It acts like the slope in a way, and it just stretches it vertically. If it's 2, it's twice as tall. If it's 5, it's 5 times as tall. If it's a half, it's half as big, so you make it smaller. But that's what that does. It does not adjust the X values. It only adjusts the Y values. Okay, did we have any other questions to look at right now on that take-home final? Sure, 29 and 38, we'll look at those. I can add those to the list. Okay, so 29 and 38. Let's look at 29. Okay, 29 is a system of equations. Let's make sure I'm the right one. Okay, question 29. Now, this is what I gave you, and I'll just work out this one because there's 2 more of them just like it. Okay, there's 29, 30, and 31, and they're all pretty much the same. Now, this is what I gave you on the systems. 2 variables, 2 equations. I think one of them's a contradiction, one of them's an identity with the, a dependent solution set, and then one of them has an actual number. I'm not sure which one it is, but we'll look at 29 here, because I can't remember if this gives us an answer or not. We'll work it out. And you can use any method that you want. I really don't care. It says use elimination, but you can use Cramer's rule. You can use substitution, which probably would be the hardest way to look at this, or you can use elimination. Really doesn't matter. It says use elimination, but let's solve this one. Well, let's use elimination. Yeah, we can easily do it. Doesn't matter, again, which technique we use. You could even use Cramer's rule. Cramer's rule would probably be the easiest way to deal with this one, but we can use elimination. So a good review of elimination. Now, which one has smaller numbers? 5 and 3 or 7 and 4? Looks like 5 and 3 is smaller, right? Because 5 and 3, remember, we look at this based upon the least common denominator. And the least common denominator of 5 and 3 would be what? Would be 15, right? If I did 7 and 4, what would it be? If I try to use 7 and 4, well, they have nothing in common. So 7 times 4 would be that 28. And I'd rather work with 15 than 28. So we're going to eliminate the x. So if I want to eliminate that x, we need a least common denominator of 15, because that's those put together. And so the top one, what do I need to multiply 5 by to make it 15? 3. Right, so that's going to take care of that one, and that's going to be distributed through. And then what about the second one? What does it need to be multiplied by to make it 15? 3 times what? 3 times 5, right? Now, they need to be opposites in signs. Are they already opposites in signs? Yes. Okay, so we don't have to change signs because they're opposites. So let's rewrite what we've got. 3 times 5, that makes it a 15x. 3 times 7, that makes it a 21y. 3 times 10, make sure you distribute it through everywhere. 3 times 10, that's 30. Next row, 5 times a negative 3, that's a negative 15x. 5 times a negative 4, that's a negative 20y. 5 times a negative 6, that's a negative what? 30, isn't it? Okay, so, easy enough to work through. When I put these together, what do I have? Well, positive 15x and negative 15x, these do what? Go away, don't they? Okay. What about 21 minus 20y? That leaves you with a single y, doesn't it? And what about a positive 30 and a negative 30? Well, that leaves you with what now? 0. Okay. How do we finish it out? We have half of it. This would only get you about half credit. How do we finish it out, and how do we get the full credit? What do we have to do? Yep, plug it in somewhere. Does it matter where it goes? No. It does not matter. Plug it in somewhere. How about we just plug it into the first one? So how about we plug in y equals 0 into 5x plus 7y equals 10. So plug in the 0. And that makes it really easy because 7 times 0 is what? 0. So now we've got 5x equals 10. We divide by our 5. And we've got our answer, which is x equals now what? 2. So as an ordered pair, what would this look like? 2, 0. Now, you've got 2 more of these to look at. I don't care how you solve them. If you want to use Cramer's rule, that's fine. If you want to use elimination, like I did here with back substitution, that's fine. Or you can even use Gauss-Jordan. But you're going to have 3 of these on your exam. They're going to have 2 variables, 2 equations. So there's no 3 variable, 3 equations. They're not that difficult. We've got enough time, I think, to do one more. So we'll look at 38, and this is going to be our last question. So let me find the sign-in sheet here. We're going to look at question 38. And I've got homework to pass back as well. Here's the sign-in sheet. And before you leave, don't forget to pick up any of your back homework. Okay, so let's look at 38. And that's going to list out just right on top. So question 38. Okay, question 38. Another easy question. This is, again, just checking to make sure that you understand how to use one of these piecewise defined functions. So what am I doing here? And there's so little on this one. Again, another concept question. There's nothing to it really. This is question 38. For question 38, they give you a piecewise defined function. And there's conditions on this. Now, what we want here is we want to find f of 3. Now, there should only be one answer. We only plug this 3 into one of the rows, not all of them. So if you plug it into all of them, I'll probably take off a point or two. Which row does it fall under? Let's label them and talk about them real quick here. This 3 is our x value. So this one is for when x is less than 0. Is ours less than 0? No. The next row is when our x value is between 0 and 2. Well, 3 is not between 0 and 2, is it? No. Where's 3 at? It's in this row, and what do I plug it into? The left-hand side over here, which is x. So that gives you then f of 3 equals now what? 3. What would have happened if I would have gave you a 1? Let's say I would have gave you f of 1. Okay, if I would have gave you f of 1, it would have to go in here. You'd plug it in, right? If I would have gave you f of negative 10, where would it have went? Into here. Right? Because this one is for numbers that are less than 0, between 0 and 2, and bigger than 2. R3 was bigger than 2, so it went here. All you had to do then was plug it in, and what is it? It's just an x, so f of 3 equals what? 3. Simple, simple question. Again, I do not want you to miss that one, because that is another concept question. So I think that'll be it for today. Please make sure you sign the sign-in sheet, and any graded homework is back up over there. If you have homework, the last day I'm going to take it is going to be December 15th, when we take our final exam. So if you want to turn things in today, you can. If you want to wait and give me more homework assignments than on next Thursday, you can do that as well. Thank you, Garrett. Just as long as I get all the homework no later than December 15th.